Shear Example 4, continued, page 7. So just to complete this, we've worked out the demand on each weld. It's equal to 1.119 kilonewtons per meter. So we've got a simply supported beam with two reactions at both sides of 1750 kilonewtons, which could only be given rise to 3500 kilonewtons. And we worked out that let's just draw the shear force diagram here. So we know that the shear force is 1750 kilonewtons, and there would be a shear. Well, if we did a free body diagram of the web, just the web, so not the weld. Let's just sketch that as a traction Q, and that value Q is going to be equal to 2.238 kilonewtons, to be shared between how many webs there are. Just drawing the tractions acting on the webs, there would also be another traction there at the position just below the weld, and on the other side it would be exactly the same. There would be a Q there, and there would be another one there. So these aren't bending stresses. They're shear stresses or shear tractions, and you can see at the center of the beam, the shear would be 0, and then it would switch directions, so that the tractions would switch directions at the supports. So if we had a look at it, if we just drew out the webs, so without drawing out the sides, and if, say, that had been a cut between those two, we would have a traction acting both sides, which if you wanted to, you could convert that into a force. And if you converted that into a force, you would probably find that the majority of the 1750 is being carried by the web, and a small amount has been calculated by the flanges, which you could calculate if you wanted. And then if we did a cut on the other side to the right of the 3500, you would find exactly the same, but in the opposite direction. Anyway, so we worked out the shear. We calculated the shear flow Q, and then from the shear flow Q, because there are two welds, we divided it by 2. And we got 1.119 kilonewtons per millimeter. So if you look at the question sheet, it gave weld sizes, and so you had 5, 6, 7, 5, 6, 8, 10 and 12, and then it had design capacities, and the first one was 0.696 and 0.835, 1.11, 1.39 and 1.67, and the design capacities are in terms of units kilonewtons per millimeter. And you should now know that the the millimeter acts along the length of the beam. So these capacities have been determined most likely through experimental tests, and we can see that we need 1.119 kilonewtons per millimeter, as we've just calculated, based on the geometry of the section. So we could see that if it was a 5 millimeter weld, that wouldn't work. If it was an 8 one, that wouldn't work, because 1.119 is slightly higher. So a 10 or a 12 or a bigger weld would suffice. So we could then say the minimum weld size is going to be equal to 10 millimeters, but obviously a 12 millimeter one would work equally as well.